In problem 6.2, we are returning to a situation that we looked at earlier this year, which is making a box by cutting a piece of paper, cutting the corners out of a piece of paper. So just in case we've kind of forgotten what that looks like, the general idea here is that if I start with a piece of paper, and then I go ahead and I cut out the corners like this, all the same size and all squares, then what I'm left with is I can go ahead now and fold each of these edges up, and these become the walls of our box. So by cutting away these pieces up here, we can make a box that has no top on it, but it has 4 walls that we make with those extra edges. Now in this specific problem, we're given some information. First, we are told that the paper we start with is 8.5 inches by 14 inches in size. And they're actually nice enough to go ahead and give us an equation or a function that tells us the volume of our box if the squares that we are cutting out of each side have side length x. And that equation is right here. So that's the big thing we're going to have to focus on right here, because that's what they're going to be asking us all of the questions about. So, first question up. Identify the degree and the leading term of the polynomial. Well, let's first of all refresh on what those mean. Degree is the highest exponent, and the leading term is the entire first piece, so the term with the highest exponent. So they're very related here. They're very connected. So let's go ahead and actually think about how we're going to do this. Now we have this polynomial here. In order to find out the highest exponent and the term that has the highest exponent, we could go ahead and distribute this entire thing, or we could distribute this entire polynomial. Or to find the thing with the highest exponent, what I can also do, and this will be a lot faster, is we can take the term in each factor that has the highest power of x in it and just multiply those. So for example, in this first factor here, I can just take the negative 2x. In this next factor, I can just take, again, the negative 2x because that's the highest power of x. And in this last factor, well, there's only one option. I'm going to take the x. So if I just multiply those together, that will give me, let's see, negative 2x times negative 2x times x. That's going to give me positive 4x squared times x, which will give me positive 4x to the third. Now, obviously, there's a lot more to this polynomial. We are just looking at the leading term. So to answer the question, identify the degree. This now tells me that the degree is 3. It's that biggest exponent right there, which we just found. And the leading term, well, that's just the entire piece that has that biggest exponent, which in this case is the 4x cubed. So there's our answer right there for the degree and the leading term. For question 2, they now want us to think about a couple other features of this function, specifically about its graph. So to find the horizontal and vertical intercepts of this graph, well, those, remember, are our x and y intercepts. We can go ahead and do some quick calculations here. To find the horizontal, or the x-intercepts, remember, we just say what makes each factor equal 0. So it's a quick calculation we can do. So we can go ahead and say, okay, I'm going to do 14 minus 2x equals 0. What makes that true? Well, I can subtract 14 from both sides, so I get negative 2x equals negative 14, and then divide both sides by negative 2, we'll get that x equals 7. So that is one horizontal intercept. Or more specifically, it's 7, 0. Another horizontal intercept is I can take that next factor, 8.5 minus 2x, and set that equal to 0. Right now I'm going to find what does x have to be here. So again, I'm going to subtract the 8.5 over, we'll negative 2x equals negative 8.5, and then divide by negative 2. X equals, let's see, negative 8.5 divided by negative 2 is going to be positive 4.25. So there is another x-intercept. And there's actually one more factor here. There is x equals 0. Well, that one's actually already solved. So there's my third horizontal intercept for this problem. For the vertical intercept, we go the exact opposite direction. We plug in x equals 0. Remember, because the vertical intercept is your y-intercept. And if you're on your y-intercept, you always have an x value of 0. So if I plug in 0 here, that first parentheses, 14 minus 2 times 0, just becomes 14. That next parentheses, 8.5 minus 2 times 0, just becomes 8.5. And that last parentheses, well, that just becomes 0 entirely. So 14 times 8.5 times 0 is just 0. So my vertical intercept is a y value of 0. Now they ask us to now figure out, do these points make sense in this situation? So let's go back to our drawing for a second here and think about this. Or maybe I'll draw a new one. Remember, x is how much we are cutting out from each corner. Right? This distance here and here is x. So if I cut out 7 from each corner, but this box is only 8.5 inches wide, that's not even possible. So x equals 7 doesn't make sense, right? That does not make sense in real life. If I cut out 4.25 from each side, well, that uses up this entire side. 4.25 from each side would cut out the entire 8.5 inches. So I would also, again, have no paper left. I cut it all away. And if I cut out 0 as the size of those cutouts, well, then I have no walls to fold up. So the horizontal intercepts, none of them actually give you a box. The vertical intercept also requires you to have, remember, x equals 0. So that again means you're not cutting out anything, which means again, that point does not make sense. So none of these intercepts actually give us a box. None of these intercepts actually result in a box. Either because we cut away no paper, or because we cut away too much paper and there's nothing left.